Okay class, today we're in section 6.1, solve linear systems by graphing. Before, you graphed linear equations. Now, you will graph and solve systems of linear equations. Why? So you can analyze Kraft Fair cells as in exercise 33. Key vocabulary: system of linear equations, solutions of a system of linear equations, consistent independent system. A system of linear equations, or simply a linear system, consists of two or more linear equations in the same variables. An example is shown below. X plus 2y is equal to 7, equation 1. 3x minus 2y is equal to 5, equation 2. A solution of a system of linear equations in two variables is an ordered pair that satisfies each equation in the system. One way to find the solution of a linear system is by graphing. If the lines intersect in a single point, then the coordinates of the point are the solutions of the linear system. A solution found using graphical methods should be checked algebraically. Example 1. Check the intersection point. Use the graph to solve the system. Then check your solution algebraically. So we look at the graph and we determine that these two lines intersect at this point. Now the coordinate of this point is x is 3 and y is 2. X is 3 and y is 2. Here's our point. X is 3 and y is 2. All right, so that would be our ordered pair or solution to this system. The lines appear to intersect at the point 3, 2. Check. Substitute 3 for x and 2 for y in each equation. So x plus 2y would be equal to, in place of x, 3, in place of y, 2. 2 times 2 is 4. 3 plus 4 is 7. Does 7 equal 7? Yes. So far it checks out for the first equation. Next, 3x minus 2y is equal to 5. In place of x, 3. In place of y, 2. 3 times 3 is 9. And then 9 minus 2 times 2, which is 4. So 9 minus 4 is equal to 5. Does it check? Yes, 5 is equal to 5. Because the ordered pair, 3, 2, is a solution of each equation, it is a solution of the system. Types of linear systems. In example 1, the linear system has exactly one solution. A linear system that has exactly one solution is called a consistent independent system. Because the lines are distinct, are independent, and intersect, are consistent. You will solve consistent independent systems in this chapter, and you will also consider other types of systems. Key concept: solving a linear system using the graph and check method. Step 1. Graph both equations in the same coordinate plane. For ease of graphing, you may want to write each equation in slope-intercept form. Step 2. Estimate the coordinate of the point of intersection. Step 3. Check the coordinates algebraically by substituting to each equation of the original linear system. Example 2. Use the graph and check method. Solve the linear system. Negative x plus y is equal to a negative 7. X plus 4y is equal to a negative 8. First thing we got to do is put each equation into y equals mx plus b form. Okay, for equation 1, negative x plus y is equal to a negative 7. I want to get the y by itself. So therefore the x must leave, y by itself. That negative x must leave. The inverse of a negative x is a positive x. I do that on both sides. So a negative x plus y is equal to x minus 7. Once again, I added a positive x to both sides. Now negative x, when combined with a positive x, goes to 0, so I'm left with just y. And y is equal to x minus 7. That's my first equation. My second equation, once again, I got to put it in y equals mx plus b form. I have x plus 4y is equal to a negative 8. I want to get the 4y by itself first, and then the y by itself. But to get the 4y by itself, I must get rid of this positive x. So to it, I will add the inverse, a negative x. X minus x plus 4y is equal to a negative x minus 8. X minus x plus 4y is equal to a negative x minus 8. X minus x, that goes to 0. I'm left with 4y is equal to a negative x minus 8. I want to get the y by itself. This says 4 times y. The opposite of multiplication is division, or the inverse of multiplication is division. So therefore, I will divide both sides by 4. 4 here, 4 here, and 4 here. 4 divided by 4 is 1, so I'm left with just y. In this case, it really means 1y. There's a 1 in front of that y. So y is equal to a negative x over 4 minus 2. Negative x over 4 minus 2. Don't forget, there's a 1 that's sitting in front of the x that we don't see. There's a 1 sitting right there that we don't see. Why is that? How many x's do you see? 1. So there's a 1 there implied. So now we're going to graph. Y is equal to x minus 7. My y-intercept is a negative 7, and my slope is 1, or simply 1 over 1. All right, so let's see that graph. Negative 7, that would be here. That's my y-intercept. My slope is 1, so it's up 1 over 1. Up 1 over 1. Up 1 over 1. Once again, rise over 1. Up 1 over 1. Rise over 1. Okay. Now my next line, I ended up with y is equal to a negative 1 over 4x minus 2. My y-intercept is a negative 2. There's my negative 2, negative 1, negative 2. There's my y-intercept there. Okay, and my slope here is a negative 1 over 4, rise over 1. Negative 1 means I go down 1, then I count over 4. 1, 2, 3, 4. There is a point of intersection, but we'll get one more point. Down 1, over 4. 1, 2, 3, 4. All right, so I got enough to make this line and to make that line. And right here is my point of intersection. Okay, we determined that our point of intersection was the x value was 4 and the y value was a negative 3. That means that it is a solution to this system here. All right, now what we're going to do is we're going to take this point, the x value and the y value, and we're going to plug it into each equation to see if it's true. So I got a negative x plus y is equal to a negative 7. So in place of x, I put that 4 down. In place of y, I put the negative 3. A negative 4 plus a negative 3 would give me a negative 7. And a negative 7 does equal to a negative 7. Equation 2, I'm going to do the same thing. In place of the x, I'm going to put 4. In place of the y, I'm going to put 3. 4 times 3 is a negative 12. So 4 times 3 is a negative 12. And so I'm going to get 4 plus a negative 12. That's going to give me a negative 8. And a negative 8 does equal a negative 8. Because 4 and negative 3 is a solution of each equation, it is a solution of the linear system. Example 3, standardized test practice. The Park and Recreation Department in your town offers a season pass for $90. As a season pass holder, you pay $4 per session to use the town's tennis courts. Without the season pass, you pay $13 per session to use the tennis courts. Which system of equations can be used to find the number x of sessions of tennis after which the total cost y with a season pass, including the cost of the pass, is the same as the total cost without a season pass? And then here are our choices: A, B, C, and D. Solution. Write a system of equations where y is the total cost in dollars for x sessions. Equation 1. Total costs will be y. Cost per session was $13. Number of sessions, x. So your equation will be y is equal to 13 times x. Equation 2. Total cost, y. Cost for season pass, $90. Cost per session, 4. Number of sessions, x. So in other words, you will have two equations. Y is equal to 13 times x, and y is equal to 4x plus 90.